Hi! In this video, we will see a demo of Intel PMEM-CSI for Kubernetes with Redis Memtier benchmark. Let's get started. CSI stands for Container Storage Interface, and PMEM-CSI is Intel's persistent storage driver for container orchestrator Kubernetes. It makes local persistent memory, what we call PMEM, like Intel Optane Persistent Memory module, available as a file system volume to container applications. We will not go into the design and architecture of PMEM-CSI in this video. You can find the details on our GitHub page. Some PMEM-CSI application examples include Redis PMEM operator to deploy a Redis cluster through the Redis operator using QEMU emulated persistent memory devices, Memcached with PMEM to deploy Memcached with PMEM as a replacement for DRAM, and Google Cloud Engine to install Kubernetes and PMEM-CSI on Google Cloud machines. Now, let's dive into the Redis Memtier demo. There are 3 steps in this demo. First, we will show how to deploy the PMEM-CSI in a multi-node Kubernetes cluster. Next, run Redis with different persistent modes, AOF, PBA, and RDB, where the pointer-based AOF mode utilizes PMEM-CSI. And lastly, use Memtier benchmark to show the performance of the 3 use cases. Let's understand the 3 Redis persistent models. The Redis Database Backup, RDB, performs point-in-time snapshots of your dataset at specific intervals. The append-only files, AOF, logs every write operation received by the server. These logs will be played again at server startup to reconstruct the original dataset. RDB files are compact snapshots, hence they are perfect for backups and disaster recovery. This model maximizes Redis performances. AOF, on the other hand, is much more durable and easy to understand. There is no corruption problem if there is a power outage, but they are usually bigger than the equivalent RDB files for the same dataset, and are not as fast. So pointer-based AOF offers a faster speed than AOF and the same durability. When Redis gets a write request from the client, it stores the key in the DRAM. Instead of saving everything as append-only files in SSD, we only store the key and the location of big values as AOF in SSD, and those big values are now saved in the persistent memory. Now, let's get to the demo. Starting from the worker node with the persistent memory installed, use IPMCTL tool to configure the persistent memory to be all in app direct mode. Then reboot. After reboot, we see the entire memory is in app direct mode, and there is no PMEM created or mounted at this point. Moving to the cluster's master node, label the worker node with PMEM installed. Navigate to the directory where PMEM-CSI repo is cloned, download the Cloud Foundry SSL tool, and use the provided script to create Kubernetes secret for secure communication between the PMEM-CSI controller and node. Create PMEM-CSI namespace and install the PMEM-CSI driver using the customize method. Here, we're using the logical volume management device mode. We now see that the driver's node pod is running on a node with PMEM, and the controller pod is running on another node. Back to the node with PMEM. Now we can see 2 PMEM disks shown in the host system. Next, deploy Redis with 3 types of persistent mode, PBA, AOF, and RDB. We see that the pod that uses PBA created a persistent volume claim, and this PVC has successfully claimed a persistent volume. Let's see what happened on the host machine with PMEM. A region is now created by the PMEM-CSI driver under PMEM0 as a LVM, and it's mounted as a volume for a Kubernetes pod. Final steps. Start the dashboard that we designed for this demo, and deploy Memtier to collect the ops per second of each Redis persistent mode. Open up the dashboard in a browser and see the live stats coming in. The pink, blue, and green curve shows the ops per second for RDB, PBA, and AOF mode respectively, and higher is better. RDB mode still maximizes Redis performance, but with Intel Optane Persistent Memory module and PMEM-CSI, the pointer-based AOF mode, shown in blue, is significantly faster than the standard AOF mode, shown in green, while also providing the persistence and durability for Redis database in Kubernetes. Thanks for watching. For more details about this project, please visit us on GitHub.